The first thing I want to talk about today is a two-way table. So just kind of remembering from what we've talked about before, the last thing we talked about was for categorical data, how to show categorical data in a graph. And then today we're going to transition to talking about quantitative data, so more about numbers. The first way we can display a quantitative data is in a two-way table. So a two-way table has two variables, a row and a column variable. So essentially what happens is we are going to gather two different pieces of information from each individual. So you've got one individual, you are going to gather two different pieces of information from them. Let's talk about this example here. So here we've randomly selected young adults, and we've asked, what do you think the chances are you will have much more than a middle class income at age 30? I want to do a little sidebar here and really digest this question. We will get into surveys in Unit 4 and what does it mean to really ask a good survey question. And let me tell you guys, this is a terrible survey question. What do you think the chances are that you will have much more than a middle class income at age 30? There is just absolutely way too much happening there. What even is a middle class income? I mean, I don't even know. So there's a lot of issues with this question, but let's not focus on that because that's not the purpose of today's lesson. We're going to get into that more in Unit 4. We can come back to this question then. Okay. So let's look at the chart here. And we've got one individual. In this case, the individual is going to be the young adult. And we have gathered two different pieces of information on them. So we're going to gather if they're male or female, and then we're going to gather their opinion on this terribly worded question. And I will just do another really quick sidebar before we get into today's lesson. This is a very dated question, so you're going to see that a lot in this class. And I think as our society becomes more understanding of the fact that maybe you don't consider yourself a male or a female, I think we'll get some data that actually reflects that. But for now, that is not really modeled in a lot of the data that you're going to see for this class. And that's really just, I mean, it's just an issue of the way we've been taking data. So this question is probably at least 10 years old. That they've, honestly, it might be more than that this data has been taken from, because you think how long it takes to gather the data, how long it takes to publish a textbook. It's been a while. So just kind of keep that in mind, and not just for this question, but for this entire class. And hopefully in the future, we'll have some data that's a little bit more, it makes more sense with the way that a human being is. So for now, I'm done with my sidebars. Let's get into the question here. Okay. So we've got one person. We've said if they're male or female. We've asked what their opinion. This is a two-way table because we have a row and a column variable. We've got our row variable is here. And this is our column variable. There. Okay, so the first thing let's talk about, besides the fact that we're talking about a two-way table, is a marginal distribution. Okay, so we're going to talk about two different types of distributions today, marginal and conditional distribution. The marginal distribution is the distribution of one of the categorical variables. So, I mean, we've got two categorical variables here. We only want to look at one of them. So let's say, for example, I don't care if you're male or female. I'm just curious about your answer to this question. And it doesn't matter among who. So when we're finding the marginal distribution of opinions, the first thing that we're going to want to do is ignore male and female, and we are only going to look at opinions. So if I were to do that, you don't really need these two columns here. You just need to look at the total of the opinion and the total of the table, which is 4,826. Okay, so to find a marginal distribution of opinions, so we're looking for the marginal distribution of opinions, means we ignore the other variable, which is male and female. For the first one, we would take the total people that said almost no chance, and we would divide that by the table. So the total people that said almost no chance is 194. We'll divide that by the table, 4,826, and we get about 4%. So there's that math there. So, I mean, again, thinking about what we're doing, we don't care about if they're male or female. We want to find the marginal distribution of opinions. Only care about opinions. So I'm going to ignore the male and female numbers here. I only care if you think you have almost no chance of achieving it, which is 194 people over the total number of people that were surveyed, almost 5,000 people, and we get 4%. Okay, so what I want you guys to do is start to fill in the rest of these. So we need to do the same math for some chance, 50-50 chance, a good chance, and almost certain. Okay, pause the video, go ahead and fill those in. So the numbers you should have gotten. So some chance, you're going to look at the total for some chance, which is 712, divide by the total, and so on and so forth. Okay. Now here, you'll see in italics there, marginal distributions don't really tell us about the relationship. Remember, we ignored one of the variables, so we don't know anything about the differences in male opinion versus female opinion. All we know is the distribution of opinions. Well, there's another type of distribution we can use. That's called a conditional distribution. And the conditional distribution converts the counts to percents. So let's look again back at our chart here. Now these numbers are actually fairly close. There's 2,300 females and 2,400 males. Now technically, we surveyed more males. So while you see more males that say almost no chance, technically we did survey more males. So, the number should be higher since we surveyed more. Assuming there's no difference between male and female. Maybe there is a difference between male and female. That's a good question we've got to ask. So we're going to take all of these counts and convert them to percents. Okay. So here's how we do that. So we're going to look at the percent of women who said they have almost no chance of achieving this middle class income. So we looked at 96 females said they have almost no chance out of the total number of females. So out of the 2,367 females, don't care anything about what the males said. All we care about is what the females said. And if you divide that out, it's about 4.1% of women who said they have almost no chance of achieving a middle class income at age 30. Okay. Continuing on, I could do the same thing for some chance. 426 out of the 2,367 women, that's 18%. So a conditional distribution is just taking all of these counts and converting them to percents. I want you to do the rest. Okay, you probably saw that coming. So pause the video and fill in the rest of those there. Okay, that's what I got. You can see my math there for women, so check your answers. Okay, let's switch gears just a little bit. You see something in a double bold box. That double bold box screams to me that this thing is really, really, really important, and it should scream that to you too. So anything that I put in a double bold box is probably something we are going to need to reference multiple times, not just the definition, but a really, really, really important thing. So what we need to do is come up with good comparison words. We are going to compare all the time in statistics. So I've come up with some. I want you to see if you can come up with some other comparison words. Okay, anything that would be good to compare two different things. So for example, I have greater than and less than, larger, smaller, more and less, equal to is also a possibility. Honestly, most ER words are comparison words. But I want you to see if you can come up with some other comparison words. Put them in your box because you'll want to reference this later. Okay, now using those comparison words that you came up with, write something about the differences and similarities between men and women. The best way to write about the differences is to use the percents because by using the percents, you've already accounted for the fact that we surveyed more males than we did females. So let's use the percents and let's compare something about men and women here on the next page. And what's going to happen is another answer box is going to pop up. Please share your answers in the answer box using those comparison words from before. All right, the last thing we're going to talk about today is association. The definition of association is if knowing the value of one variable helps predict the value of another. They are associated with each other. Do we know whether knowing that you're male or female has an influence on how you would respond to this question? We might be able to make some guesses. However, we don't know if an association exists. And I'll be honest, you guys, this is a really tough question. So it's kind of the focus of what we're going to be doing, especially first semester, but a lot second semester too, trying to figure out if these two things are related. Maybe there's some confounding variables that are getting in the way and causing us to think there's an association, but there's not an association. And this is kind of the premise of what we're going to be doing this year. So we can start to kind of make some guesses. We definitely can write comparisons, but we don't know if there's an official association between these two things. That's it for today. We'll talk more next time.